Alright guys, welcome to this page of the notes, and again, as promised, we're not going to do any new algebra. You should recognize the three properties I've got written up here. Here's the first one. There's property number 1, property number 2, and property number 3. You'll recognize them as the exponential properties of logarithms. The only difference now is that I've just simply replaced the log with an ln, right? The base E logarithm. This is the product property for exponential properties of logarithms, where if you have multiplication, we can rewrite it as addition, or if you have addition, you can rewrite it as a product. This one is if you have a quotient, you can rewrite it as subtraction, or if you have a difference, you can rewrite it as a quotient. Again, be able to go either direction with these. We got a lot of practice with this in the previous section, and this one's the power property, right? Where if your argument is raised to a power, that power can be dropped out front as a coefficient. We talked about all of this. I spent a ton of time going over it in a previous section. If you have forgotten these or you don't recognize them, go back. Should be section 6 of, section 5 of chapter 7. I spent a lot of time going through these properties. Here we're just reviewing them. Let's show you how they work. I want you to simplify this guy. So here we go. I take a look at it and I recognize, ooh, I got a coefficient out front. That coefficient is going to become an exponent on the 10. Let's do that first. So I'll have the ln of 10 to the third minus the ln of 8. Oh, and then I recognize, hey, this is a difference, which means I can use the quotient property of exponents to rewrite this guy as a quotient. Remember, it'll be 10 to the third. It's the first goes on top, the second one goes on the bottom. So this will reduce or simplify to the ln of 10 to the third all over 8. Again, if you wanted to, you could do 10 to the third, which comes out to be, 10 to the third, 1,000. 1,000 divided by 8, which again would just be the ln of 125. So there we go. We wind up with the ln of 125. This whole thing simplifies to ln of 125. Next one, 6 is going to become a power. The 2 is going to become a power thanks to the power property. So I will have the ln of 8 to the 6th minus the ln of 4 squared. I can rewrite that as a quotient because of the quotient property of 8 to the 6th. Oh, sorry, hold up. Those look weird. Which I can rewrite. 8 to the 6th power, I got a calculator here, is 262,144. 262,144 divided by 4 squared is 16. And if you were to do 262,144 divided by 16, you should get 16,384. So there you go, simplified using those properties of logarithms, exponential properties of logarithms. Nothing new. We've seen them in a previous section. Now we're just applying them to this natural base logarithm. I got one more for you here. Here we go. The 2 is going to become a power. The 4 will become a power. Nothing I can do there. So we're going to have the ln of 5 squared plus the ln of 2 to the 4th plus the ln of 5y. Okay, no problem. Because it's addition and addition, I multiply all of these guys together. So the ln of 5 squared times 2 to the 4th times 5y. ln 5 squared is 25. 2 to the 4th is 16. Multiply those together. 25 times 16 times 5 is going to be 2,000y. So it simplifies down to the ln of 2,000y. Again, all the properties of exponents and properties of logarithms we've already learned are going to show up again here. No new algebra, just applying what we've already learned to this new exponential, natural base exponential function and the natural base logarithm ln. Head on over to the next page of the notes and we'll take a look at a few more things. I'll meet you there.